Dave here with Coolfall. Today I'm going to go through the details of how the Vegas knob were made and how it functions on the inside. This is the body. I'm going to show you a close-up here right off the bat. That knob goes on this boss here on the body, and you can see that there is a little protrusion there, a boss that sticks up, and inside of the knob there are a series of holes, 7 holes. One hole is for off, and then the other 6 power levels. And when that pin is sticking through one of these holes, if it's sticking down through far enough, then it will hit on this stop boss, I call it. Now, if you look at these 2 pictures I have here, this is the knob in its locked mode, and here it shows that pin sticking down through. I'll give you a little picture of this beside it. There we go. That's the pin, and in this case it's showing that pin coming down through into this cavity here. This is the cam cavity that's cut, that this little pin, this little stop boss protrudes into. Here the pin is in the locked position. The crown is all the way down, and here the crown is all the way up, and this is called the spin position. And when it's here, this pin has been pulled up out of this area right here. Now, the way that this all works is there are races cut into this body here. They're shown as a cross section here. You can see 3 of them here. That's 1, 2, 3. There's one race that goes all the way around, and then there's the next one down, and it goes all the way around, and then there's one more even deeper. The little crown has little holes around its perimeter. This plastic one only has 2, but there's actually 4. And inside these holes goes one of these little springs and one of the little 1mm balls. There's a spring, and there's one of the balls. Not easy to see, are they? Those balls are always being pushed out. And so as this crown moves up and down in the 3 different positions that it can be in, that ball pushes into the whatever race it's next to and keeps it there. So I've got some other pictures here. This shows the crown in the locked position with the ball in the lock race. This one shows it up 1 click. This is the ball into the what I call unlock race. And then this last one shows the spring pushing the ball into the spin position. When the crown's all the way up in the spin position, this pin has been pulled up out of these little white holes here. And when it's up out of those holes, then it can rotate. So if I put it in here, it can rotate into position. And then when it clicks to the location you want it, you push it in. When you push it in, if you look down through the bottom here, you'll see this little pin is sticking out. And that's pretty much the mechanism that makes the crown engage into position and interface with the stop boss on the body. I have Mike here with me. Say hi, Mike.
Hello.
Mike and I are going to try and explain very quickly what the machining processes were, just generally, that it took to make these parts. It matters in that they were machining intensive and very complicated parts to make. I'm going to start with it's the Vegas body, as it were, and the inside of the body in what I would call the back, it kind of it's very similar to the military knob. That's the first machining process, right? The tool comes in and it pretty much makes the inside of the knob where it slides onto the body. It also creates the knurl and the O-ring grooves and this face here where the dice marking will eventually get machined into. The part gets severed, and then the next operation is on the mill, right?
Correct.
Okay. So the way we use the mill is we'll have a very large vise, and it'll have aluminum jaws or steel jaws that are machinable, and we'll make special cavities in the jaws, and the parts will sit down in those cavities. In this case, in the second op, this is being held in that vise, and the tools come down and they cut this cavity down through here. There's a special lollipop shaped tool, or
correct,
Woodruff, or yeah, it's a tool that we had custom made. Goes down, it cuts these races, and then a centering drill comes in, right? So center drill comes in, it picks these 7 hole locations, then a drill comes through and drills them, and then a ream comes through and reams them. It's kind of standard, only that it's just so tiny. We found that when we machined this piece and the crown, we literally needed to make sure that they fit together, so we kept checking them as we were going through the machining process. We would grab a crown that was coming off and seeing that this bearing surface, this is this post that sticks up here in the middle, was exactly the right size. Once the part is done in the mill, which is a couple different ops, one on the back side and one on the front side. The back side is machining the threads. The front side here machines those races. Then it goes on to a 4th axis fixture that holds the part at an angle, which makes that conical shape horizontal. And a very small, what size cutter?
1/64.
Comes down, and this piece is then indexed into a location, and that little 64th cutter will come down and machine in the little dice markings. So these little holes that are in the front of this thing are 15 thousandths in diameter in the little lines. And then what happens when the part is nearly complete, we fill those little holes with epoxy, black epoxy, jeweler's epoxy. And to do that, you can't get epoxy to go down into a little hole because there's kind of like an air pocket there. So you paint the epoxy on and you put it in a vacuum chamber, and the vacuum chamber will cause the air to expand so many times that the little bubbles will all come out. And then when you let off the vacuum, the epoxy will completely fill the little teeny dice marking cavities. And we have a couple more operations back on the CNC tool to cut that epoxy away without damaging the face of the part. And then ultimately, as you may have seen in some of my other videos, there is a 6-axis polishing robot that will take this piece and put a really nice polish here and on the knurled part. And that kind of covers that part. The crown is such a small piece, but it is a complicated piece to make because it also has critical timing features in it. I'm going to demonstrate with the larger one here. It's all one piece of titanium, and it gets machined from the crown side first, and that knurling is put on there, and then the part is drilled. There are 4 holes that get drilled around its circumference, and those holes are timed with the divots that are inside the races in here. Then the part goes to the lathe, right? The lathe drills and reams this hole, and then finally the part goes onto the mill, and a cutter comes down, and it's cutting away all the metal and just leaving this little pin. We wanted this pin to be solid and an integral part of the piece. We didn't want to bore a hole and push something in there because I was afraid that wouldn't last forever. These parts are solid titanium, and they're going to work today. They're going to work 20 years from now the same as they do today, because there's no glue, there's no press fit features, there's nothing to change or melt or come unglued in time. We cover everything?
Yep.
Thank you for watching. Please click like and subscribe, and check out all my videos on the support page at coolfall.com.